So the motivation to do this is that oftentimes housing prices will follow a bi or multimodal distribution rather than a unimodal one. So they're an appropriate application of Gaussian mixed models. And the underlying reason for this is that houses in different neighborhoods or different parts of town might follow a different distributions. So my data was obtained from Kaggle, and the original data was housing houses from all of Russia, but I took a subset of only houses from Moscow. The data that I ended up with had about 5 categorical attributes and 98 numeric attributes, and most of these attributes do not pertain to the houses themselves, but rather pertain to their proximity to different attractions. So stuff like how close they are to parks, what bus station or railroad station they're near to, how many coffee shops are within a certain radius. So information such as that. And naturally, it follows that a lot of these attributes are highly correlated with each other. So houses that are in a more urban area are going to tend to be closer to everything, and houses that are in a more suburban area are going to be further from everything. And in the case of a Gaussian mixed model, this actually isn't such a bad thing, because when we build the model, the only attribute that goes into the model is the prices themselves. So this correlation doesn't affect the model like it would maybe with a linear regression or something like that. And when we do our cluster analysis later and evaluate the clusters, it's kind of nice that these attributes are all correlated with each other, because that means we have to evaluate fewer attributes. So the original distribution of prices looks like this. It's kind of difficult to tell exactly what the distribution is. It may be unimodal, it may be bimodal, it may be multimodal. It should also be noted that the attribute that was most highly correlated with prices was square footage of the house. So originally built our model based on it having 3 nodes. Oftentimes, depending on the kernel used, it would converge on something like this. We see on the left with the 2 steep distributions and the other one on the right. And it just doesn't seem like this wasn't exactly the type of granularity we were looking for. I didn't really think that there was going to be too much of a difference between the 2 left distributions, and it didn't capture the one on the right very well. And then the other issue with using 3 nodes is sometimes it would converge on something like this, and in this case the blue curve is basically useless and doesn't tell us anything. So when we use 2 nodes, it tended to almost always converge on something like this, with the left distribution and a right distribution. The mean of the right distribution doesn't match up very well with that little bump, but it does sort of generally group them into 2 groups. So when we compare the clusters of the 2 groups, well, we find that naturally the price of the right distribution is much higher, and so is the square footage. And that result is not very interesting. If the real distribution were unimodal, we would expect this too. So we're really interested in seeing how the other attributes vary between the 2 clusters. So one interesting result that we found is that a much greater proportion of the ones in the right distribution with the higher prices tend to be close to a certain metro station. About half of them are by metro station 140 versus 3/20ths of the other one. So this would indicate that there might be a nicer neighborhood or more urban neighborhood where more expensive houses tend to cluster. And other results that we found that were consistent with this were that the right cluster tended to have more coffee shops, tend to be closer to parks and entertainment and offices. So in general, there was a good indication that it was a more urban neighborhood being modeled over there. And because Gaussian mixed models are soft clustering and give probabilities rather than a hard group, we can vary how strict we are with our clustering. So if I tried bringing up the probability of a model being in a certain cluster up to 65 rather than 50, and the results there, we actually saw less of a difference between the prices and the square footage than when the requirements were more lax, but the trend where the right distribution tend to have more people of that certain metro station actually increased when we made the requirements stricter. So again, that indicates that there is a different neighborhood being modeled in that right cluster. So that is all that I have for this presentation. In the final report, I'll have more analysis on the inter and intra-spread of the clusters and looking more at the distribution of the various attributes in the different clusters.